By the end of this lesson, the students will be able to define homogeneous system, illustrate homogeneous system with examples, deduce an expression for equilibrium constant Kc in terms of concentration, calculate the value of Kc in terms of equilibrium concentration of reactants and products, relate Kc and Kc prime. A system is the part of the universe that we wish to study. In our study of chemical reactions, the chemicals in a container is the system. If the reactants and products are in the same physical state, the system is called a homogeneous system. Drag and drop the reactants and products to form a homogeneous system. Summary: a homogeneous system is one in which the reactants and products are in the same physical state. Consider the reaction A reversible B. Click the Start button to view the particles of A and B in the system at regular intervals. How does the ratio of the number of particles of B to the number of particles of A vary with time? The ratio of concentration of B to concentration of A increases with time, but remains a constant eventually. A state of equilibrium is attained when the ratio of the concentration of the products to the concentration of the reactants is a constant. This constant is known as the equilibrium constant K. Consider the above reaction. Click the Rate of Forward Reaction button. The rate of the forward reaction is directly proportional to the product of active mass of the reacting substances A and B. Click the Rate of Reverse Reaction button. The rate of the reverse reaction is directly proportional to the product of active mass of the reacting substances C and D. Click at Equilibrium button. At equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. Click the Equilibrium Constant button. Equilibrium constant Kc is the ratio of the rate constant for the forward reaction to the rate constant for the reverse reaction. The concentrations of the reacting species are expressed in terms of mole per cubic decimeter. If C plus D minus A plus B is equal to 0, Kc is dimensionless. How will you calculate Kc based on equilibrium concentrations? To see its calculation, click Next. SO2 reacts with O2 to form SO3, and the equilibrium concentrations at a certain temperature are as shown. What is the expression for the equilibrium constant of this reaction? Click the Kc button to check your answer. Drag and drop the appropriate values into the boxes to get the value of Kc. Summary. At equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. The equilibrium constant in terms of concentrations is expressed as Kc. For the reaction, A moles of A plus B moles of B, reversible C mole of C and D moles of D. Kc is equal to C power C into D power D upon A power A into B power B. Kc can be calculated using equilibrium concentrations. Units of Kc depend on the concentration terms in the expressions.